Yes, sir, Bob.
So later in the year, we are going to have a unit on the unit circle. This will all make a lot more sense when we get to unit circle. But right now, this whole crazy image that you see up in front of you is where trigonometry is derived from. So, does anybody know anything about trigonometry yet? And I have your tests. Remind me to hand them back because I failed in the morning class to remember, but I have them. They're graded. They're ready to hand back. What do you know about trigonometry? Stravler?
I know the basics.
What do you mean? Like,
I know SOHCAHTOA how to apply them to a triangle. They give you solve for like cosine, and they give you like this stuff.
what do you mean solve for cosine?
Like
When do we use sine, cosine, and tangent?
when you're doing trigonometry.
But what's the point of trigonometry? Like, what's the goal? Why do we use this whole sine, cosine, and tangent? These things.
To find the lengths and angle measures of
So we use it to find any unknown value of the triangle. If I know the angle measure, that is represented by, well, they don't even have it here, but we will use a symbol called theta. So another way to write these, if you want an easy way to write these, is that sine of theta is a Greek symbol, looks like an Easter egg. So, SOH, over here, this SOHCAHTOA thing. What does SOH stand for, Stravler?
So, sine opposite over hypotenuse.
So we've got sine opposite hypotenuse. So that becomes sine of the angle equals the ratio of the opposite over the hypotenuse. So whatever that ratio is, whatever it turns into as a decimal value, the trig when applied will give me my answer. But we seem pretty good here. Make sure that we're getting work, people. Hey Josh, decision making. Is that the right choice? No. Alright, you know what it is.
Oh, I thought he was gonna go like whole.
I mean, Mr. Hudson on there.
Yeah.
Not to us.
So the one thing that really screws people up with trig is your values or your numbers that you're trying to find can be represented in different ways. One way that we're used to is degrees. But there's another way. Anyone know the other way we talk about angle measures, which actually relates to our unit circle, if you know anything about that. But if we don't use degrees, the other thing that we actually talk about is how far we've traveled on an arc. So when we think back to that circle up there that you can see on our start slide, the arc that they have highlighted in bold, we actually have a way that we can calculate the distance traveled on that arc. So even though it's a curved line, we can calculate that distance, and that comes out to be a measure in radians, which is actually unitless, because its unit comes from whatever unit the circle or the triangle that I'm working with itself has. But right now, the biggest thing that you want to care about is if you're using a TI-83, or any TI really, but most of the 30s default into degrees, in your settings, if you're using one of these, it'll say it across the top, but in your settings, you want to make sure that you have DEG up at the top here. It actually says the whole degree. Or in the TI-30, I forget how you get to it, second science English. There's a button that says DRG. If you hit that, you have the options degree, radians, and GRD. I forget even what GRD is. You want to make sure that you're set up in degrees, otherwise this won't work. So I suggest, so that we all practice these calculations, if you don't have a calculator, I would come grab one so you can practice actually typing these things in. Maybe, yeah. Clean, slippery. Do you have braces? Remember what it felt like when you got your braces off?
They really do.
I got
Braces
while I was doing that. Not like while I was doing it, but like
braces sting.
So if I was you, under your SOHCAHTOA, I would write out all three of these. Now, the thing you want to notate is all of your thetas. Sorry, I have to grab black. All of your thetas are angle measures in degrees. Yeah.
You put SOHCAHTOA.
Oh, my bad. Good catch. I did that on purpose. And all of these values are just your side lengths. Now, if ever people get screwed up with this, it's dealing with the adjacent. The adjacent side has to be the side touching the angle that isn't the hypotenuse. So, if anybody screws that up, that's normally the only issue that I see. So here, if you were asked to set up all three ratios, and we call these trigonometric ratios because it's comparing the side lengths. If you were asked to set up these ratios, the sine of my angle t, because sine is opposite over hypotenuse, my opposite leg is 8. Because t is right here, we look opposite across the shape, gives me the 8. And then the hypotenuse is adjacent to it, but the hypotenuse trumps the adjacent. So this is actually the adjacent side to t, because the hypotenuse is my other adjacent. For cosine of t, cosine is adjacent over hypotenuse, so now we use the 15 over the 17. And then tangent, opposite over adjacent, we use the 8 over the 15. Any questions about how we set up those ratios? Now you might be thinking, well, this is kind of dumb. That doesn't actually tell me anything. We just found some ratios. So on your calculator, you will probably notice above sine, cosine, and tangent, what do you see? An inverse sine, right? You see sine to the -1, cosine -1, tangent -1. So here, and we're going to practice this today, but where this would be useful is then, oh yeah, they do angle G. So let's solve angle T really quick. I can use any of these to solve angle T, because all I have to do to get rid of, let's use cosine just because it's in the middle. To get rid of our cosine, all I have to do is apply an inverse cosine to it, because the inverse cosine times cosine cancels each other out. It's like a number and its reciprocal. They just become 1. So these are honestly reciprocals, because the inverse cosine is 1 over cosine, because if you remember our rules about exponents, our exponent of -1 comes from that value having been in the denominator, if you remember those rules about exponents. So this is like 1 over cosine times cosine over 1. They cancel each other. So what I really have to do over here is apply the inverse cosine, which writing it like this is wrong. It would be inverse cosine and then parentheses the 15ths, 17ths. But if on your calculator you hit second to get the inverse cosine, so it should pop up sine to the -1 with a parentheses open, put in your ratio 15 divided by 17, close your parentheses, and as long as you are in degrees, this should come out to give you an angle measure of approximately 62, if you round.
Wait, I have a question, Mr. Hudson.
Sorry, I did inverse sine. My bad. That's wrong. I bet you I just figured out angle G.
To do inverse, then
I just figured out angle G. My bad. So, I'm going to do it again down here.
Wait.
So don't worry if you didn't totally keep up with us.
Now I need more.
Caleb.
So wait, alright, this might just be like how I calculate the calculator. But for a calculator, would you not need to like clarify that you're doing inverse then a thing? So I wouldn't need
As long as you use the inverse button.
Alright, so if I don't need to put negative cosine, then the ratio.
No, because the negative cosine with the cosine is happening on the left side. That cancels automatically.
Oh, okay.
Your right side is the only side that actually has math happening.
Okay, cool.
So let's practice this on the next one. I want you to set up your three ratios, sine, cosine, tangent, for angle G. So G is your reference angle. Yeah. So inverse cosine. Sorry, I had hit sine accidentally. Ah, you're in radians. So if you got an answer that doesn't make sense, like 0.489957, raise your hand. I need to change your mode. So we go to mode. See how it's in radians? We gotta go and click it to degrees. Always go to mode. That's your main menu. So I can second quit. I can do that. Sorry, not second answer. By second entry, grab my previous entry. Now I get my answer in degrees. That's why I told dude, the settings are really important. And guys, I will warn you, on the common assessment, like on the air or end of course exam or whatever, you might need to switch back and forth between modes. So be comfortable selecting your modes, whether it's radians or degrees. With whatever calculator you prefer, be comfortable selecting those modes. Do not look up here if you are trying to do this on your own. Which actually, so now instead of using theta, I know the angle that I'm referencing is angle G, so I can say sine of G. And we might as well go ahead and fill in our numerical. Well, I'll write out what it is and then fill in the numerical. So sine of G, Carmen, what is sine? What ratio gets set up from sine? Don't give me the numbers, give me the names first.
Opposite over hypotenuse.
Yeah, it's so, S-O-H, so it's opposite over the hypotenuse. So that becomes what? 15 over 17. Notice that these will be different than our ratios from T. Ethan, what about cosine? What ratio should that be? 8 over 17. So that came out of CAH, which is adjacent over hypotenuse. And tangent, Caleb.
Tangent, oh, you want to do the opposite over the adjacent.
We want to do the opposite over the adjacent. So that would be...
That would be 8 over... Wait, sorry, opposite. Sorry, 15 over 8.
Ah, careful there. So now choose one of these, I don't care which, and take the inverse of the trig function and input this ratio. Whatever ratio you choose. So if you choose sine and you do inverse sine, you'll have 15/17. If you choose cosine and do inverse cosine, you'll use 8/17. And if you use inverse tangent, you'll be using 15/8. Caleb?
Wait, can I say the answer?
Give me just a second. Give everyone a second. Because all of our answers, regardless of whether you chose sine, cosine, or tangent, all of them should be exactly identical.
I realized that after I did all 3.
After you did all three.
I'm getting there, Mr. Hudson.
And you should get the answer that I accidentally got on the last one of Caleb. What'd you get?
61, well, 62 rounded.
Yeah, it's 61.93, so it's approximately 62 degrees. Anybody have issues finding that? Okay.
Now I got it.
No, we're doing the inverse button. You gotta hit second and then that trig button. Yeah.
So when would we not use the inverse?
If I know the angle. So the reason I have to use the inverse is this is an unknown value, and I have to get rid of anything attached to it.
Yeah, okay.
So this is like 3g. How do I get rid of 3? Divide by 3.
Yeah.
We're essentially dividing by sine.
Okay.
But it's not a value, it's an operation. So we have to apply the inverse operation as opposed to being able to do anything to remove a value.
Okay.
Does that make sense? Yeah. Other questions? This is weird. I understand.
Why are they called sine, cosine, and tangent?
Research that.
Okay.
That we don't have enough time today to go into that, and that's not really part of the standards. So, like, it's interesting, well, depending on your brain, but look it up. It's pretty easy to find the answers. So, I'm going to bring this in tomorrow, and I meant to today when I stopped by home, but all I did was get food, because I was in a rush. I texted a couple people. Thank you guys. So, what?
For our blended project, when does that actually do?
As soon as you can. He wants to come and do lunch and buy you guys food and stuff, like whenever you're done. So, okay. They're doing a side project for a friend of mine, a 3D printer project. Do you know how to model in Blender? You just want. Okay, so. Hey guys, I'm gonna bring this in tomorrow, but to talk about have I talked about my stairs at home, my trim work?
Oh, yeah, you talked about that.
Okay, then I'm not going to retell the story. I'll just bring in the stuff tomorrow, then we'll talk about it, because I'll use my little document camera to show you. But seriously, so you guys know, Olivia Taylor's sister.
Abby Taylor.
No. Layla. No. That's not, I know Layla is her sister. That's not who I'm thinking of. Somebody and their mom, I can't think of who it was now, followed me home the other day. It was really weird because we were doing pickups for the garage sale. But then we started talking about home construction. And I, like the renovations that I've done, I pulled out the notebook that I use. And I'll bring in my actual notebook tomorrow. This thing shows you just how nerdy I am. But the math application in there is the way that I can do stuff on my own as opposed to paying somebody else. And a lot of fine woodworking and like mechanical things comes down to relatively simple math. Huh? No. How could I mark a piece that, so if I have my stairway coming down like this, and I have my floor like this, and I have a square trim piece, how could I mark my trim piece with this line? But how can I see through the trim piece? Once I set the trim piece up against this, if I set it right up against it, it's on top of it, and I can't see where the line is. I mean, I could mark the very bottom corner and mark up here and try to draw an approximate line, but it's still when I... But then, how do I set my saw blade? Do I just try to match the line? That's not going to be perfect.
You can find the angle of it.
So, you're... Well, what do you mean you could find the angle of it? I could get a protractor and find the angle. I do agree, but what if it's not a nice one? My saw blade goes to every half degree. Can you really get that accurate when you're looking on a protractor? You can maybe get within every 2 degrees. Most protractors maybe give you every single. But dude, you're not going to get an accurate reading from just sticking a protractor up there.
Sand it down?
Yeah, but I don't want to do extra work. I want to do one math problem and get the perfect cut the first time, which, not to toot my own horn, but I did. So, math... Sure, but math is the way, because here's the thing. Those trim pieces come in 12-foot boards. If I screw one up, that's a 12-foot board that costs like $10. Yeah, but what if I screw it up again and I get I'm just wasting money? Instead, I can just do the math. Well, I know. That's why I'm not going to hire Brian. When?
So what if you took a sticker and put it non-sticky side down where you wanted the line to be, and then stuck the thing on?
Yeah, I mean, there are other creative non-mathematical ways that you could solve this problem. I'm not saying that there aren't. What I'm saying is the most efficient and most accurate way to solve this problem is through the utilization of trig. And that you can't really argue.
Then you have extra stickers.
Well, yeah, but then I can put them on my face and stuff. Okay, moving onward.
Brian arguing's never gonna get you anywhere.
Moving onward.
What have we learned from Miss Goldring? What have we learned from Miss Goldring?
That you should put your feet on my side.
And that you shouldn't argue.
You want to know what I learned from Mr. Allen? You don't have to go to college to have a good life. That was his word of wisdom. You know what
I have a friend of mine who has not graduated college and he just opened a school. He's a teacher. Does not have a college degree. Alright, can we move on?
Yes, sir.
But how is that possible?
I don't know exactly. I'm going to take my discovery day and go shadow at his school and figure it out. Yeah, that's a great question. If you were engaged with our conversation, you'd know, but now I need to move on.
Your buddy opened a school. I heard
So, this degree right here is 5 degrees. this right here is the Leaning Tower of Pisa. So, we know, now if you don't know about the Leaning Tower of Pisa, it's sweet. They built this giant tower, but they didn't know to give it a good enough foundation. So the foundation, wasn't that solid, and it tilted, and everyone kind of freaked out, but then it stayed there, and it's stayed there forever. So it's just a tower that's leaning.
It's gonna
Why
fall
don't they have
eventually.
why don't they have like a crane or something like push it over?
Because they could destroy it. So,
Won't it fall over? No. Stop being a hater.
hey guys, read the problem. Engineers' efforts were successful. By tilting the tower back slightly, it had gone all the way to a tilt of 5.5 degrees in 2001. In 1990. They had actually closed it. They would not let anyone in it because they were afraid it was going to fall the rest of the way down. So just like you said, I don't know exactly how they did it, but they did compensate the tower back and put stuff under it to keep it from being able to tilt any further. And then they were able to reopen it after they fixed that degree. But they figured out 5 degrees is within the safe zone. What we want to know is if I drop something off the very top of the tower and it falls perfectly to the ground. Let's say Brian's at the top of the tower and Caleb's at the bottom, and Brian wants to hit Caleb. Because that's, they always got to screw with each other. Where
You just jump out to hit me.
should Caleb stand? How far away from the tower? So now we know our degrees. And we know, if I know this angle right in here, what side is this relative to the angle? Opposite, right? What side is this relative to the angle? Adjacent. So I need to use whatever trig function involves opposite and adjacent. Which one is that? Tangent. So we set up that tangent of 5 degrees is going to equal the opposite over the adjacent. Now, I'm trying to solve for my x, not for my degree measure. So what is currently happening to x, and how do I undo that? I know one's wrapped up, but you got a hand, right? Good game last night, by the way. I got some great pictures of you guys. So what do we do, Brian?
Oh, you multiply.
Multiply what?
150.
Where?
Everywhere.
Everywhere. Both sides. So now, this is when we just type in one thing and we get our side. So, type in 150, then punch your tangent button, not inverse tangent, because now we don't need inverse, we can just use tangent. So 150 tangent of 5, making sure your calculator is in degrees, and we get the value for x being 13.123.
I have a question.
Wait, Mr. How do you set that up?
So I multiplied 150 on both sides.
No, I mean, how do you type it?
So in my calculator, I'm typing in 150, and then I can hit multiply if I want to, but I don't even have to. I can just then hit tan
Okay, I got you.
5.
Alright, I got you.
Yeah,
Did you get a good picture of me last night?
I got pictures of all you guys.
Thank you.
You look really short out there. I'm just going to put it out there.
I know.
He looks short everywhere.
I hadn't even realized that it was you, and then I looked at my arm and I was like, oh, that makes sense, because I wrote your guys' numbers down on my arm just so I could keep looking at it.
What number am
Did
I?
you give me
You are 80 or 85?
11.
11. Okay, I don't know. I gotta be watching you guys to know who you are. When you're out there, I can tell, because you're different heights and stuff.
I'm the smallest one on my team, so you already knew.
You guys played good D. Dude, I'm telling you, that right before first half was over, and Cardinals had gotten that touchdown that wasn't a touchdown, it got reversed because there was a flag on the play, I thought your D-line was going to hold them for the rest of the first half. You guys did, that D-line held really well, and then it just kind of, they got there with a minute left. You guys did well. And I think you guys were kind of set up from the get-go. Apparently Cards just have better athletes. I don't know why. That's what I got told, is somehow the feeder schools, I know, and I was talking to Dr. Bowers about that after the game, and he's like, yeah, it's an anomaly. We don't know what happens. In the middle school, they're really good, and then it flip-flops when they go to the high school. Somehow.
How does that work?
I don't know. Mathematically, it doesn't make sense in my head.
It could be coaches.
One thing I wasn't going to say. But I didn't say it.
Oh, I'm sorry.
No, don't
I'm
apologize. I just said I wasn't going to say it.
Mr. Hudson
Solve
was gonna say what he can't
For the
do.
value
That's not
of
okay.
W. I want to see if you know which trig function to use, how to set it up, and how to use your calculator. Solve for the value of W.
17. Oh my god.
It absolutely cannot be 17.
I know. I was just making sure everybody didn't take my word for it. Building distrust.
Oh. What?
Max, what trig function should I use here? Sine, which would give me the opposite over hypotenuse. Well, the opposite of 54 is W. The hypotenuse is 17. Those are the other two sides that I know. Wonderful. Now, the only other way you could have done this, I'm curious if anyone did, because each year I've taught somebody has, is you could figure out this angle and then use a different trig function if you wanted.
I was thinking about it.
So I know there's always those ornery people that are like, oh, I know what he wants us to do. I'm going to go do this. So you could, obviously, since this is a right triangle, solve for your other angle and use a different trig function. But with what we have right now, we're stuck using sine. Carm?
Could we use that 90-degree angle?
We cannot. You can never use the 90 degree as a reference. In your calculator, do sine of 90 degrees and see what it gives you. Do cosine of 90 degrees, see what it gives you.
Uno!
Cosine of 90 degrees
0!
and tangent of 90
Domain arrow!
Why? Why is it a domain arrow?
because, and this will make more sense when we do unit circle, sine and cosine are the relative x and y coordinates. So at a 90 degree angle, one of them is nothing and the other one is all the, so the unit circle, this is going further than I should, so warning now, if you don't get this, that's fine. In the unit circle, we start right here with our rotations, and we rotate counterclockwise. So at 90 degrees, we would be right here at this location. So the sine value, which gave us 1, is actually asking what is the y coordinate? Essentially, how far above this center point. The cosine is asking what's the x coordinate, or how far away is the x from my center coordinate. And tangent is something totally different. But, so this point right here on the unit circle having a radius of 1, would be at the value of 0, 1, which is my cosine and sine. So we can't use the 90 degrees because it'll always come out to be 0 and 1 or 1 and 0. Whether I use 90, 180 or the other, like it just doesn't work because it's not in between here.
So then why is tangent a domain arrow?
So we can talk about tangent another day. I want to make sure we get through all these notes. Sorry, we have been chatting a lot and I got to make sure we keep on our progress. So then here, what do we want to do? Max, I'm going to come back to you.
You would multiply 17 on both sides.
Yep, and in your calculator you type in
17 times sine 54.
and you get
13.8.
and we don't know our unit measure, so units.
Wait, would you label it units just because you don't know?
Yeah, because really, if you want to be proper, we should have no naked numbers. Every number should either have a degree, a sign, a unit.
Yeah, he's like.
Exactly. You don't want the number to get arrested.
Yeah, right.
Get thrown in the tank.
Yeah.
In the tank.
The other numbers are gonna.
I think 17.
Unless he goes to a naked number beach.
Oh, then it's okay.
Like spooning.
What?
Now you took it too far. All right. Now to solve the degree measure. This is an example. So all we need to do is compute this. But so that when you're doing your homework, you have something to reference back to in case you don't write stuff down. We set up our ratio based off the sides we know. We use inverse on both sides. So really, if you want to show that work, we'd have inverse sign out here, inverse sign wedged in kind of right there. That means now that my angle x will become the inverse sine of 6/10. So what does angle x become? In my notation, there's kind of redundant. Sorry, I said the measure of the angle with size of... Go.
36.869897.
So 869.
887.
Ah, nearest degree.
Calculator
But
doesn't show me up.
I never count off for accuracy. So it's okay. If you would have had the 36 point yada yada.
What do you
you'd be
have to
fine.
state, Calvin?
And this one is degrees. Make sure you always label your angles with your degrees.
Will you take points up if you don't end?
Yeah, because I'll probably write on their dogs, cats, pizzas, question mark. Because especially when we're doing trig, if I don't know whether you're talking about the angle size or the length, your number kind of doesn't mean anything.
When we do it, like write down the angles, like the units, and then turn it back again.
Yeah, that's all I would. But you could just do units the first time.
Yeah, Brian's not that good. Mr. President,
Yeah.
Would we ever, for any reason, have to solve like two angles or? Wait, that's a stupid question. Never mind. Keep going. Actually,
In
it's a right
order-
triangle, and if you find one of them,
Yeah.
the other.
So in order to do trig, we have to have a right triangle. And actually, this is worth it to take a second and look at the unit circle just so this makes a little bit more sense. Let me see if I can find a good... Really, unit circle is a chapter that we cover later in the year because we need to do a little bit more learning first. So this, if you were to make... And these measures are also in radians. So, if you make this a right triangle, and this is 30 degrees, your, I don't want to switch them around, your sine, I just want to make sure I say this right, your sine is this value, and your cosine is this value. So your cosine is how far off the horizontal, and your sine is how far over from your vertical.
And then, yeah, then what about tangent? Is he like voodoo mystery man not on there?
Just let me verify this. And 6. I believe.
Or is it the pile?
Hold. I just want to check this before I tell you. Okay. Your tangent, and this is why for 90 degrees it doesn't know what to do. Your tangent. God, I've put all of these pens other places around the room. This arc length, which is notated right here, that is your tangent.
What?
So, sine and cosine are dealing with horizontal, vertical, straight lengths.
Okay.
Tangent is dealing with the arc length. So the measure as it rotates.
So the bigger the circle. the
What?
bigger
Sorry, what?
What does the domain mean?
Domain error is just a calculator error that it spits out when. So domain is the inputs that you're giving it. It doesn't know what to do with the inputs. So really, the arc length there becomes pi over 2, but your calculator can't it can't fathom that because you can't use 90 as an input, and it knows you can't use 90 as an input for tangent. So it just says I can't compute this.
Okay.
So on your calculator, do sine of. Actually, no. What do you notice about the 30 compared to the 60? If we're going to talk about unit circle, I might as well go into it a little bit.
Oh wait, things are flipped. Yeah,
Oh,
they're flippy
I was looking at the other thing.
Think about these two triangles. These two triangles are the same thing.
What? What I said.
30, 60, 90. 30, 60, 90. So they just trade places. The same thing happens the whole way around the unit circle. But now I go negative on my x, still positive on my y, negative on my x, positive on my y. Now I'm negative for both of them. And then I start to get positive
This is a cool
again.
picture. I like this picture.
So, when we get into unit circle, please come into it with, now I will tell you, true confessions, I never really understood the unit circle in high school. I don't think my teacher taught it that well, and I never understood the relationship that it had with trig. And that sine is really just your y values, and cosine is really just your x values. But now that I do understand it, the mental trick I use, cosine, if I think alphabetically, C comes before S. X comes before Y. So they're like in order alphabetically that cosine relates to your X value and sine relates to your Y value. Can we jump back to the notes? This is your taste of the unit circle. More yet to come. Yeah.
Could another explanation for tangent not working be because the opposite is the hypotenuse and it has two adjacent legs? So
Yeah.
it would work trying to solve it.
So you're saying because tangent of, like, let's hypothesize 90 would be opposite, which both of them are the same.
Well, the opposite is the hypotenuse, which it would say hypotenuse.
Oh, yeah, so it would
it's
cancel itself.
And then the adjacent, there are two adjacents, and it doesn't know which one to pick.
Yeah.
So that could also be a factor.
Well, yeah, because the adjacents are the same. Yeah, that's the issue. Okay, we're going back.
I got an understanding now. Thank you.
Unit circle is really quite fun. I know you don't
We
believe
get to
me.
eat pie.
Yes.
This is just another example. So, hey, Carmen. So, once we input y inverse cosine of 15 over 20, what do we get? Max, you got it?
I have it.
Go ahead.
41 degrees.
And let's finish out with one more got it. Find the measure of y and p.
Why?
Because once you know y, you should know p.
Because you have to.
Because he said so, be right.
Anybody confident enough they want to come show it?
Let me finish. I got it.
What other angle do we have to figure out?
You're just figuring out both here. And then down here you're just solving for x. And then down here you are just solving for angle x. No one, like, you have to have your mouth open for like an hour. It's just like so annoying.
Is that your wedding ring? It's just like black. Whoa. You weren't wearing it yesterday.
I know, I forget.
Whoa. It's wood.
What?
Wait,
Check it out. It costs $10. My original one got too small. It's titanium. It's really sweet, but I just bought it a little bit too small. Never buy a ring in the middle of the winter. Because your fingers shrink up because of the dry air and everything. I bought my ring in February.
When I was getting large, that's what my mom did.
Yeah, so then I bought this one off Amazon because I always loved the wood inlay. My dad's a woodworker. I love like nature. The nature. I was gonna say the woods. I was gonna say the woods, and then I was gonna say nature. Yeah. Yeah, I'm gonna do that right now. Be right. You wanna come solve this?
No.
Right.
Oh!
Oh, wait, no, hold on.
Wait. No. Hold on.
Hold on, Ryan. Do it.
I love the name.
You're good.
Post.
I'm a car guy.
Alright, okay.
Ria's got nature.
But I got it better.
Probably not.
I don't know what you're talking
I
about.
have one more.
47,
You know, I will own my mistakes from now on. It's referred to as the nature. I'm gonna go team the nature.
Did I tell you that? Did I tell you that I have an entire list of like quotes from you?
68.
I love it.
No, I didn't know. I'm not surprised.
Oh no, I have a long list. I started in like 2, I think.
Wait, so in the
I'm a
goddess,
somewhat quotable person, I guess.
in the goddess, do you want us to
Solve for first. So in the goddess, you were solving for angle P and angle Y. And the next one, these were just bonus questions that I put on there. You were solving for length X, and then the next one you were solving for angle X. Yeah.
If I didn't actually get these right, would I still would have matched me? Yeah,
Try them and then come talk to me.
Dude, that's your graduation song.
Try them and come talk to me.
But if I don't get them like this,
Try
do I
them.
have to do them?
Nature got the quotes in here.
What does this say? Finish
If I
for
don't
mastery.
I don't want to finish.
It's not mastery if you don't try this, because these are both the same skill set. So if you can't solve either of those, you're showing me you've not mastered that skill. So if you can't do either of those, it's progressing. If you can do at least one of them, then we can chat. By the way, guys, thank you very much. Your homeworks are looking awesome, so please keep that up. I appreciate. Sorry, go ahead.
I said I wasn't done, but you still graded it.
That's because you were done enough for me to grade it.
What?
If you want to put more work into it, and then I can go back and look at it. But she showed me that she had mastered those skills.
Bananas.
Ryan got rotisserie.
And I meant to circle that, accidentally circled that first, then I was like, what am I doing? Just ignore it. When things don't make sense, I was grading late at night.
Okay. Wait, Mr. Hudson, how
Yeah.
many questions can we miss for mastery?
That question does not have an answer. It is not a strict question number. As I was just explaining to Brian, he essentially could have left those 2 questions blank and gotten a progressing, because that is enough to show me if you can't solve that skill set problem, you haven't mastered it. But if you have like a small mistake here, a small mistake there, so like it's about skill mastery, not doing the math perfect every single time. You know what I mean?
By the way, Mr. Hudson, the worst.
Huh? Yes, I do.
You asked.